Hello, welcome to another 5-minute masterclass. Today's topic is distance time graphs. So a distance time graphs plotting the distance an object travels against the time it takes to travel. And what you find is time is always on the x-axis, how far along we are, whereas distance, how far we've travelled, is our y-axis. And that's true for all distance time graphs. Now, before we even start answering questions, I just want to show you this journey here. So we'll watch what the car is doing on the left-hand side compared to how we are plotting this distance time graph. Okay, so before we even answer questions, I want to show you that again. So my car is going at a constant speed. It then is stationary for these 2 seconds. It then goes at a faster constant speed and then it's slower. So you can see at the different parts of this graph how it can illustrate what has happened to that car. So answering these questions then, how far did the car travel in the first 3 seconds? We're interested in where time, which is along the x-axis, was 3. So I'm going up to my graph from 3. We go along the distance and you can see it's travelled 60 metres. For our second part then, how long was the car stationary? Now if it's stationary, it's not moving, which means that we're not travelling any distance. So we are looking at the horizontal lines. Now the horizontal line on this graph is here between 4 and 6. So for how long was the car stationary? What's the difference between the 6 seconds and the 4 seconds? This gives me an answer of 2 seconds. Careful with the units, make sure you're in the diagram to use the correct one. Is it seconds, is it minutes, is it hours, etc. Third question, what was the car's greatest speed? Now thinking back to our science lesson, speed is distance divided by time. So our distance is our y-axis, our time is our x-axis. So we're interested in the change in y and the change in x. And we can calculate that by considering this triangle here. Now I'm using it in this plot because it's the greatest speed, that's the fastest part of our diagram because it's got the steepest gradient. And notice the links to the gradient work when we've been doing linear equations and line graphs of straight lines. So to calculate our greatest speed, remember speed is distance divided by time. Our distance is our height, which is 100 metres. I'm going from 80 up to 180. Our width is our time, so we're going between 6 and 8, so we're going 2 seconds. So speed, distance divided by time, 100 divided by 2 gives me an answer of 50 metres per second. Finally, I'm interested in the average speed for the whole journey. So again, I'm not changing the rule. Speed is distance divided by time, so I want the whole distance and the whole time. So he travelled 220 metres in total, and it took 10 seconds for the entire car journey. So I'm going to go 220 divided by 10, giving me an average speed of 22 metres per second. Our second example then, I've already got a completed distance time graph. We've just got 4 questions here for us to work through. Now this graph is showing a cyclist's journey from home to the next big city and back, and that's really important to notice that and back. So we know that this distance isn't just going forwards, up, but we can also see that when we come back down to our x-axis, we're calculating the journey back again. So how long in total was the cyclist stationary during the journey? Now we said in that previous example, we are looking for where we have a horizontal line where our distance isn't changing, which is in 2 separate parts here. Now watch our axis. This isn't 1 hour, it's between 1:30 and 2. That's half an hour. Whereas here, we're going between 3 and 4. So that means we've got 1 hour and 30 minutes in total. Okay. Poppy, how far did the cyclist travel in total? So the cyclist is travelling all the way up here, which is the furthest distance away. And don't forget, it's travelling back. So looking across, reading across onto our y-axis, we can see that's halfway, so that's going to be 35. But he came back again as well, so we'll go 35 miles there, 35 miles back, gives me 70 miles in total. What was the cyclist's speed on the way home? Speed, distance divided by time. So the way home is where we're going from the first point away back to 0 because we're coming back. Our distance there is 35. Our time is 2.5 hours. So 35 divided by 2.5, because speed is distance divided by time, gives me the cyclist speed of 14 miles per hour. Finally, we're interested in the greatest speed. So the greatest speed is where we've got the highest gradient, the steepest gradient, which in this case is going to be at this part of our diagram here. Our height and our distance, we're going from 15 to 35, which gives us a height of 20 miles. Our time, we're going between 2 and 3, which gives us an hour. So the greatest speed, distance divided by time, 20 divided by 1, gives me an answer of 20 miles per hour. Over to you, so pause the video and try this question. When you're ready, press play. Now mark your work. Let's try it again. Pause the video and try this question. And now you're ready. Mark your work. If you're still unsure, you want further practice, we've got some Sparks Core Bit of Maths Genies places for you to look at. Thank you for your time. I'll see you again for another 5-minute masterclass.